Welcome to today's lesson in technology. I hope you're all well, and I hope you are ready for tomorrow's assessment. It will cover the term 1 and 2. Yes, the term 1 and 2 work that we did. And I think it's a beautiful test because it will test basically what we have done here in class. And I know that I have repeated many times the questions that you will be finding in your test tomorrow. So all the best. I trust you guys. Okay, let's see what we have today. Today we'll do mechanical advantage and speed advantage. We are doing mechanical systems, the speed ratio and mechanical advantage, gear trains, calculations about gears. All right, let us look at mechanical advantage and speed advantage. I think by now you know the general formula for all systems in mechanical advantage. It's load divided by effort. So in any system, if you have to calculate mechanical advantage, you look at the load and then you divide it by effort. So it's input, it's a output divided by input. All right. Let's look at the mechanical advantage and speed advantage. A mechanical advantage means that the turning force at the output axle is greater than the turning force at the input axle. Okay, in all systems that we have done, if a system where the output is less than the input, especially with levers that we have just done, it is because the advantage that you find in that system is one of distance, and the output arm is longer than the input arm. Okay, now with gears, it's still the same. Where we get mechanical advantage is where the output is greater than the input. So because it's gears, you know, gears rotate on an axle. Okay, the center part of the gear is where the axle is. So that is where your input is. So you look at the turning force at the output axle. It should be greater than the turning force at the input axle. Whether that gear system is being rotated manually by hand or it's powered by a power source. But mechanical advantage is when there is greater input, then where there's greater output than the input. Okay, I hope you guys are still listening. But now gears, they are wheels with teeth. So these teeth become very important when we have to calculate, when you have to do gear calculations. They can increase or decrease the turning speed of a wheel or axle, the teeth, because we know that gears mesh with their teeth. So they sort of control each other's motions. The teeth of two gears mesh together so that if one gear turns, the other gear will turn as well in the opposite direction. We know that now. A small driver gear connected to a large driven gear will change a fast turning speed into a slower turning speed. I made an example of the gears of a car. Okay, we know that when the car speed is low, the car will be in a lower gear. But when the speed accelerates, then the car will be at a higher gear. It just needs to be at a high gear. You can even hear the sound of the engine that, you need to move the gear to a higher one. So the small gear results into a slower speed. This gear system will make the wheels turn with a greater turning output force than the input force of the motor. This system gives a mechanical advantage. Okay. A large driver gear connected to a small driven gear will change a slow turning speed into a faster turning speed. This system gives a distance or speed advantage. Okay. So when the small gear is the driver, we don't have speed. We don't have speed advantage. Okay. This gear system will make the wheels turn with a greater turning output force. Okay. And that is what we call torque. Let me tell you, grade 8. When I am driving my car up a steep slope, okay, I change down to a lower gear to give the car power to drive up the steep slope. So the smaller gear has a bigger mechanical advantage. When the smaller gear is the driver and the bigger gear is the driven, the speed is slow. We don't have a speed advantage, but we have a mechanical advantage. Okay? Why? Because now my car has power to drive up the steep hill. So that is torque. There is bigger turning force. Okay? The output force is bigger when the small wheel is the driver. Practically, you can ask your parents or your uncles and your aunts, watch them when they are driving up a steep hill. They change to a lower gear so that the car will have enough power to go up. We call that torque, and it is mechanical advantage of the gear system. I hope you understood that one. This system gives mechanical advantage, but when you make the bigger gear the driver and the smaller gear the driven, what happens? The car moves fast. It moves fast. So when the bigger gear is the driver, you have speed advantage. Right? A speed advantage means that the speed of rotation of the driven axle, the output axle, is faster than the speed of rotation of the input axle. That is when the bigger gear is the driver. Remember, for the bigger gear to make one full rotation, the smaller gear will have made a number of rotations, and that gives speed in the output. Okay, right. Did you understand me, children? Are you with me? I want you to understand this. It's very basic. When you study engineering further, somebody will ask you, didn't you ever learn this in the lower grades? Didn't you learn this at primary? And you must remember that, oh, we had that teacher who taught us. They said, you don't understand? Okay, it's okay, my child. You must tell me if you don't understand. You must tell me, okay, when I come to the gear trains, I will explain it because I will have a diagram there, right? I like it when you talk. Right, the speed ratio and mechanical advantage. If a gear system gives a speed advantage because of its gear ratio, then it will give you a mechanical advantage. This means that if a driven gear revolves faster than its driver gear, it gives less turning output force to the machine, but it gives speed advantage. If a driven gear revolves slower than its driver gear, it gives more turning output force to the machine. Okay, and that is speed advantage. That is mechanical advantage. If a driven gear revolves slower than its driver gear, then you have your mechanical advantage. Speed advantage is when a driven input gear makes the driver gear rotate faster, then the gear system gives a speed advantage. Lalilan, listen, grade 8. When you have your gears like this small one is the driver, and this big one is the driven. Okay, let's count the teeth on this small one. We have 5 teeth. Now, how many teeth do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. If the driver gear turns clockwise, which way will the driven gear turn? You answered that one yesterday. It will turn anti-clockwise because 2 matched gears will always rotate in the opposite direction. Right, now we have counted the numbers. Count the number of teeth in the 2 gears in the illustration. On the right, how many revolutions will the driver gear need to turn to make the driven gear turn once? Okay? We said we have 5 here and we have 10 here. Did I count 10? This is 5. It's 10. Now, can you answer this one? Try and work it out. This is the driver, this is the driven. This one is turning once. How many for this one to turn once, how many times must this one turn? The input is here. Grade 8. Hello. In other words, this big gear is double the size. Chetza, you're right. Two times. Okay, why? Why do you say that? Chetza, 2 times, Nhlanhla, you're right. Why? Why do you say 2 times? 10. Okay. The bigger gear has 10 teeth and the smaller one has 5 teeth. So the bigger gear is double the size of, it's double the size. Yes. 10, which is the output, is divided by 5. 10, which is the output, is divided by 5, which is the input, and our answer is 2. Okay, very good. Preston, I like your calculation. That is a mechanical advantage formula that you used. Yeah. 10 Chetza also, you're correct. Yes, output divided by input. Very good, Chetsa. Nice. Nice. My grade 8 is smart. Love you guys. Right. So, that is the answer. You've given me the answer. So proud of you. Okay, this is because the 5 teeth on the driver gear will turn the driven gear halfway around and has to turn another revolution to turn the rest of the teeth of the driven gear as well. But I love the way you just worked it out. Perfect. It won't give an advantage. It won't give a speed advantage. Natalie, it doesn't give speed, but it gives mechanical advantage. Remember, Natalie, we said when the bigger gear is the driver and the smaller gear is the driven, what do we get there? The output is speed. We get more speed. But when the smaller gear is the driver and the bigger gear is the driven, we don't get speed because the speed slows down. We don't get speed advantage, but we get a more turning force. We get, I can say in plain English, we get more power. And I made the example of a car driving uphill. A car driving uphill cannot do that with a big gear, but it does it with a smaller gear, lesser speed, but great power. That power in technology, we call it torque. Okay, a car needs torque to drive uphill. And for the car to get torque, we need to make the smaller gear. Was I lagging, my child? Okay, Natalie. I'm sorry about that. I think my network was bad for some time. When the driver gear is the smaller gear, we get mechanical advantage. We don't get speed advantage. Okay? Torque. 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 Okay? Okay. Will this system give a mechanical advantage? How do you know? The answer is yes, because the rotational speed of the output gear is slower than the rotational speed of the input gear. If the rotational speed of the output gear is smaller, it means that the turning force of the output axle is bigger than the input axle. Okay, that's how we know that we get mechanical advantage, right? A large driver and a small driven gear, I've already explained this. Will the driven gear turn faster or slower than the driver gear? Explain your answer. So the driver is the bigger gear now. The driver is the bigger gear now. So what is the answer here? Torque, it's T-O-R-Q-E. It's turning force. Turning force. We call it torque. So when the smaller gear is the driver, then the output becomes torque, more turning force. Torque. T-O-R-Q-U-E. Okay? Yeah. Yes, that's it. Correct. You're smart. So, here's our answer. The driven gear will turn faster than the driver gear because it has fewer teeth than the driver gear. The driver gear has 10 teeth and the driven gear has 5 teeth. How many revolutions will the driver gear need to turn to make the driven gear turn once? That one is very easy. You can just chorus answering this one. What is the answer? How many revolutions will the driver gear need to turn to make the driven gear turn once? No. 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 Half, Musa. You're right, Natalie. You're right, Natalie. It's half. 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 Half, my children. Okay. Hello, Enoch. Right. Now, this driver gear has to turn half a revolution to make the driven gear turn once. Okay? This is because only half of the teeth of the driver gear will have meshed with all 5 of the driven gear. All right? Remember, this one is double the size of that one. So you have to really see it. Okay? Will this gear system give a mechanical advantage or a speed advantage? Very easy. Very easy. Speed. Smart. To give us speed advantage. All right. The driven gear will turn faster than the driver gear because the driven gear has fewer teeth. All right. So this is your car traveling on the freeway. Okay. So you are using the bigger gear and the speed is very high. Ma'am, my kettle was not working yesterday. It didn't work when you switch it on. My mom said, I think it's the element that has finished or something like that. Is it true? Is that true? If not, please explain what it is. It could be the element, Maling. Yeah, it could be the element. I hope he didn't turn the kettle on without water. Because if you do that, then there is short circuiting. Remember, we talked about short circuiting the other time? Okay. Natalie, did I start lagging when it's important? Yeah, it could be the element. Your mom is right. She might be right. Now let's just look at idle gears. What does an idler gear do? You see, there's the idler gear. We have the driver gear, and the idler gear, and the driven gear. And I think by now we all know the function of the idler gear. Grade 8, grade 8. You want to answer? Answer, Natalie? All right. An idler gear is a gear that turns between a driver and a driven gear. It rotates the opposite way. Therefore, why do we need an idler gear? Of course, it will rotate the opposite way because any 2 meshed gears rotate in opposite directions. But what do we use the idler gear for? It allows the driver of the driver and the driven gears to turn in the same direction. An idler gear does not change the mechanical advantage of a gear system. Okay, it just allows the 2 gears to rotate in the same direction. Because we say 2 mesh gears, they don't rotate in the same direction. When we want an output to be in the same direction, we just introduce an idler gear. Okay, this is called counter rotation. Any 2 mesh gears have counter rotation. So to allow them to rotate in the same direction, we introduce the idler gear. When an idler gear is used between the 2 gears, the direction of rotation of the driver and the driven gear is the same. This is called synchronized rotation. The opposite of counter rotation is synchronized rotation, because 2 meshed gears, they rotate in opposite directions, but when we introduce the idler gear, then they turn in the same direction, and that is called synchronized rotation. Okay, so whenever you are asked, what is synchronized rotation? Then you will know synchronized rotation is rotation in the same direction. Okay, what do we use for synchronized rotation? An idler gear. Okay. To make, does a clock have an idler gear? A clock. Because it should. It should, because we do want those needles, the one for the hours and the minutes, and there's even one for the seconds. We do want them to rotate at different speeds, but in the same direction, clockwise, all of them. So they should be an idler gear. Okay. Will the idler gear turn faster or slower than the driver gear? The idler gear will turn faster than the driver gear because it has fewer teeth than the driver gear. It is smaller, so it will turn faster. Will the idler gear turn faster or slower than the driven gear? Explain. The answer is the idler gear will turn faster than the driven gear because it has fewer teeth than the driven gear. Will the driver gear and the driven gear turn at different speeds? Explain. No, they will turn at the same speed. For each tooth of rotation on the driver gear, the idler gear will rotate one tooth and the driven gear will rotate one tooth. So if these two gears are equal, and the idler gear is smaller, the idler gear will turn faster than the driver and the driven, but the driver and the driven will turn in the same speed if they are equal, all right? Will the driver gear and the driven gear turn in different directions? No, they will turn in the same direction. The idler gear turns in the opposite direction of the driver gear, and the driven gear turns in the opposite direction of the idler gear. So the driven gear turns in the opposite direction of the idler gear, but in the same direction as the driver gear. All right? Then let us look at bevel gears. We did a little bit of bevel gears yesterday, but we'll do them again today. Right. Here's the bevel gears, right? These bevel gears, they have a rotation in different directions, all right? The top gear will turn in a horizontal axle, this one. Here's the axle. It's turning in on a horizontal axle, this one on a vertical axle. So there is an angle of 90 degrees between these gears, right? This one turning on a vertical axle. It is parallel to the ground. Okay. Okay, I will show you where the bevel gears will be used. Okay, here, this is where you use the bevel gears. I just brought in this picture so that you can see. There's the one bevel gear and there's another one. So there's the input. That's where where the crank is. And this is a hand drill. So this is moving in a rotation. They're all rotating. The crank is making circular movements, and this gear is rotating vertically. And it's making a vertical rotational movement. This one is making a horizontal rotational movement. Okay, but this one has a vertical axis and this one has a horizontal axis. Okay, so for this movement, for this vertical circular movement, the output is a horizontal circular movement. Let me ask you an interesting question. Why is it that this gear, this one on the vertical axis is smaller? Why did the designers of this make this other gear smaller? What is it that they wanted to achieve? Grade 8. Yes. Speed. Very good, Natalie. Very good. You're clever. They wanted to achieve speed advantage. Okay, because when you are drilling, the input, do you think the input is, do you think there's mechanical advantage here? In other words, my question is, do you think the output is greater than the input? The input force, is it greater than the output force or smaller? The input is greater. Grade 8, grade 8. Hey, the way you're answering, you're just saying greater, greater. I want to know what is greater. Okay, the output force is smaller and the input force is greater, but there is speed advantage because the output gear is smaller. So you have to put in a lot of force, input force there, but the process will be quicker here because you have speed advantage here. Let's check here. This is an egg beater. You have your bevel gears there, and let us look inside. We had to turn this so that we can see. You have this one bevel gears, and it is meshed to those small gears inside there. All right, but it's still a bevel gear train, if you may say so. All right, so it's the same thing. Have you ever noticed how fast these extensions move when you beat your egg? Okay, they move fast. You have your input force there, but you have speed advantage. This is very quick when you turn the crank here. So in this system too, you have speed advantage. All right. Ma'am, why is it that these bevel gears are not 90 degrees? They are, my darling. They are 90 degrees. The angle is 90 degrees. It is. It's a right angle. When you look at this one, it's upright, it's vertical, meshed with this one, and this one is horizontal, so the angle is 90. And even this one, just that it's lying down here, but let us look at it this way. There must be a gear here. So when you look at this one, it's upright, okay? And this one is horizontal, this one is vertical, this one is horizontal. Where they intersect, they make a right angle, so that is 90 degrees. Okay? Can you see the angle? Yeah, Natalie. Okay, all right. The egg beater and the hand drill. Do you think that the hand drill gives you a speed advantage or a mechanical advantage? I've answered that one. It gives a speed advantage because of the small output gear, which will rotate much faster than the big input gear. Explain how the bevel gears on the drill work. Both the big input gear and the two small output gears are bevel gears. This gear system changes the direction of rotation from a rotation around a horizontal axis of the big input gear to a rotation around a vertical axis or for the small output gear. I hope that you can even now draw a systems diagram for these systems. Né? Okay, what is the input? What is the process? What is the output? All right. Let us look at gear ratio. All right, gear ratio. Look at the two mesh gears in the illustration. Here we are. Yeah, it is still the 510 gear train. The driver or input gear has 5 teeth. The driven or output gear has 10 teeth. If the driver moves 1 revolution, it pushes 5 teeth on the driven gear. We've already seen that. If the driver gear moves by 2 revolutions, then the 10 of the gear's teeth will be moved. We agreed, we are satisfied with that. You've seen it now. So the driven gear moves 1 revolution. 2 driver revolutions give 1 driven gear revolution. So the turning speed of the driven gear is half the turning speed of the driver gear. The speed ratio, which is the same as the gear ratio, okay, is 1:2, or half. Remember, when we calculate speed ratio, we are asking for how many times does the driver rotate against the number of times that the driven will rotate. So that gives us a ratio answer. If the driver gear revolves 10 times, then the driven gear will only revolve 5 times. Very easy to calculate because the driver is half the size of the driven. All right? So when the driver revolves 10 times, the driven will revolve half the number of times, which is 5. Happy? I hope we all understand now, don't we? So this system is an example of the one we said has torque. All right? Yes, happy. Okay. So let us look at the calculations and the formula. Yes, let's talk. So this is the ratio, right? The gear ratio is the rotational speed of input axle divided by rotational speed of output axle. Okay, rotational speed, right? Or number of teeth on output gear, that is now the load, divided by number of teeth on input gear, that is effort. Load divided by effort equals 2. This one will be 1:2. That gives you a ratio. This one gives you an answer, which is just a whole number, 2. Right? So this is the speed advantage. Right. This, the speed of a turning wheel is measured in revolutions per minute, or RPM. You will see this in the dashboard, on the dashboard of your parents' car, or just check a dashboard of a car that you can see. You will see RPM, revolutions per minute. Okay, so if the driver gear is turning around twice every second, it has a speed of 2 revolutions per minute. A speed of 2 revolutions per minute on this system will give a speed of 1 revolutions per minute on the driven gear. RPM stands for revolutions per minute. The gear ratio can be used to work this out. Let's see. Right, driver gear speed is equal to gear ratio from that other calculation times driven gear speed. So gear ratio, we already have the gear ratio is 1:2 or half. So it will be half times 2 revolutions per minute. The answer is 1 revolution per minute. So the driver gear speed is 1 revolution per minute. Revolutions per minute. Was I fast, Nhlanhla? Okay, Nhlanhla, I will go back. We are talking about revolutions per minute of this system, okay? For us to calculate the driver gear speed, we want to know the driver gear speed. So when we want to get the driver gear speed, we have to know what are the revolutions per minute. So that's what we want. So the answer will be in revolutions per minute. All right? So, Nhlanhla, we are saying we want to get the speed of the driver gear. This is how we get it. Gear ratio multiplied by driven gear speed. Okay. So, we already know that gear ratio of our system is 1:2. So this is how we put it. 1/2, 1:2, times 2 revolutions per minute. So when you multiply half by 2, you get 1. So the answer is 1. So the speed of the driver gear is actually 1 revolution per minute. Yeah, we don't say revolutions per second. We say revolutions per minute. Okay. We don't say revolutions per second. Okay. The speed ratio and mechanical advantage. If a gear system gives a speed advantage because of its gear ratio, then it will give you a mechanical advantage. This means that if a driven gear revolves faster than its driver gear, it gives less turning output force to the machine. We already know that. If a driven gear revolves slower than its driver gear, it gives more turning output force to the machine. Speed advantage, when a driven input gear makes the driver output gear rotate faster, then the gear system gives a speed advantage. So that's the difference between mechanical advantage and speed advantage. Speed advantage is when the smaller gear, mechanical advantage is when the smaller gear is the driver, and speed advantage is when the bigger gear is the driver. All right. So I had prepared for you some assessment to ensure that you understand, but unfortunately, in the interest of time, we cannot get into the questions now. I hope you will do perhaps in a later lesson. All the best for your assessment. Let me love you and leave you. Grade 8. Have a lovely evening. Bye. Bye, grade 8.